Hello guys, this is Kentronics. I trust we're good. It's been a while. Yeah, I'll say thank you to all my subscribers and for those viewing for the first time, please do well to subscribe. Yeah, and if you have questions, please post them in the chats and we'll be available to answer your questions. Yeah, so I want to give look into that private VLANs. Yeah, what's private VLANs? Private VLANs are a technique using computer networking to enhance security and network segmentation by isolating devices within a VLAN. Mm? This isolation is achieved by dividing a VLAN into smaller subdomains, each its own set of rules for computation. So now see what the VLAN. VLAN came in about, we have we start with hubs, then from hubs went into switches, and the typical hub just has one broadcast domain. And the problem with that is in a broadcast domain, if a device wants to connect to is looking for a device, it shouts, sends a broadcast message, and it sends to everyone. But if there's a loop self in a broadcast, it affects everyone, brings down the whole network. Yeah. So the concept of VLAN is to break down that broadcast domain to smaller broadcast domains. Yeah. To segment those networks. Each VLAN has its own separate broadcast domain. That is the concept of VLAN. Yeah. So now with PVLAN, you're having VLANs within a VLAN. Yeah. So then give you a background story. Normally when you have maybe you have an enterprise environment, you have servers within a VLAN. So the idea of that is that VMs or virtual machines within that VLAN, they cannot communicate with each other. If, for instance, if an attacker should compromise the system, from that system he could easily hop from one VM or from one machine to the other one. But however, what if we have a scenario whereby if a VM is compromised, you can't hop to another one? So most places, what they do is most enterprise environments, what you do is you probably in your fabric environment, you only do inter-VLAN inspection. So if a server is trying to communicate with another server in another VLAN, then it will be inspected to say, okay, is this server permitted actually to access that VM or that machine server in another VLAN? But however, it is within the same VLAN, so as not to waste resources and all that. There's really no inspection happening most times. Yeah. So so with PVLAN, you're able to solve this issue. So let's go. So key concepts: primary VLAN. What's a primary VLAN? This is the main VLAN that encompasses the entire PVLAN domain. It acts as a layer 3 gateway out of the VLAN and is part of every subdomain within the VLAN. It acts as a layer 3 gateway out of the VLAN, is part of every subdomain within the VLAN. So primary VLAN, that's your PVLAN. Some also call the interface with the PVLAN Promiscous ports and all that. Yeah, I'll explain that later in detail. Even the layer 3 gateway out of the VLAN, yeah, it could be an IRB, that is Juniper, or it could be an SVI interface referencing the primary VLAN. That's the main VLAN. Yeah. Then we also have secondary VLANs. These provide layer 2 isolation between ports in a private VLAN domain. So we have two types of secondary VLANs. We have the isolated VLANs and we have the community VLANs. Yeah. I said we have the isolated VLANs and we have the community VLANs. So isolated VLANs, ports in isolated VLAN can only communicate with Promiscous but not with each other. So if we have VMs within the isolated VLAN, VMs or servers referencing the isolated VLANs, they can't communicate with each other even though they are within the same VLAN. However, they can communicate with other VLANs going out through the Promiscous interface. They can communicate with the Promiscous port. So they can communicate with Promiscous port. That they can always communicate with the Promiscous ports. That's Promiscous interface. That's a layer 3 interface. The interface going out, they can communicate with that. But they can't communicate with community-VLAN. They can't communicate with Promiscous port going out and other VLANs going out. Yeah. Community-VLANs, ports in the community-VLAN can communicate with each other. So servers referencing the community-VLAN, they can talk to each other and with Promiscous ports, but not with ports in other community-VLANs. I hope we get that. So now, Promiscous ports can communicate with all other ports within the PVLAN, including isolated and community ports. So Promiscous ports those data interface. So if you have a Promiscous interface, you can have like majorly an L3 interface. Let's say you have an SVI or an IRB. Let's say if you have a VLAN, your primary VLAN is VLAN 50. Mm? And then you have an IRB, that's IRB.50, referencing your VLAN 50. That that VLAN is your Promiscous port. So VMs, probably have a VM or server referencing the isolated VLAN or the community VLAN, they all can reach that IRB or SVI interface. Or if you have your gateway, or even if you have, you can also do inter-switch connection. We'll get into that. Isolated port can only communicate with Promiscous ports. So any of them isolated or communicated ports can communicate with Promiscous ports. But VMs within an isolated ports within isolated VLAN reference having isolated VLANs can't communicate with each other. However, VMs referencing the community port VLAN can communicate with each other. Do we get that? Yeah. So before I go into configurations, so I'll give you like an example. Let's say for instance you have your TMZ environment. Uh, you have maybe some segment of the network you're running Kubernetes environments and all that. You can put those ones in community VLAN because you have some pods and all that that need to talk to each other and all that. Then you also have some sets of VMs which you don't expect that they talk to each other. They are all standalone. You could put them in your isolated, having isolated VLAN. Then when those VMs when they are on the outside, so out on the outside is as they are coming in as VLAN 50, which is your private VLAN. But however, within the private VLAN concept, your server, your switch knows that this particular VM or server is having an isolated VLAN or is referencing a community VLAN. Let me bring throw more picture into it. You have your VM environment, you're running probably VMware, you're running vcenter, and then you create your VMs here. You have your distributor. So in vcenter is your distributed switch, not normal switch. The default switch, the distributed switch supports private VLAN. So here you have your normal physical switch, the VM plugged in, your management interface and all that. So you create VMs. Let's say you have three VMs for instance, or two VMs. You have one configured with your community VLAN. I'll go with this picture. You have one configured with your community VLAN. Let's say this PC3 configured with your community VLAN, and then you have, let's say, PC1 configured maybe in isolated VLAN. So in this concept, let's say we have just flow with me. Let's say the main VLAN now is VLAN 50 or VLAN 500 in this case. So VLAN 500 is our main VLAN, and then we now say okay, our isolated VLAN is VLAN 50, and then we now say okay, our community VLAN is VLAN 51. However, these guys, all of them are /24. So if you have any VM, you can give it 50.20, 50, all of them in that whole /24. But however, the reason that differentiates them is that VMs in the isolated, you can with the IP with the VM, the what separates them is the VLAN tagging, right? So isolated VLANs, the ports. So isolated VLAN and what do you call it? Community VLAN. This test here was using the switches to test the concept of isolated VLAN and community VLAN. Yeah, so if you go through like what this diagram shows is using the switch. So if I plug a PC to a port, let's say port 10 or whatever, port 12 or port 10, and it's referencing port 13, sorry, community VLAN, and then I have another PC community and I plug it and it's referencing probably the isolated VLAN. You see both systems can't ping each other. However, if both of systems are in, let's say, VLAN 5, the community VLAN, you find out that they can ping each other. If both systems are in isolated VLAN, you find out they can't ping each other. Don't worry, we're going to do next video, we're going to do a demo session. So that is that. However, if there's an IRB interface on this switch, let's say IRB.500, which is referencing the primary VLAN, that will be the Promiscous port. You see that interface can ping any of the systems, and you could also ping even the systems in the referencing the isolated VLAN. And there's also the concept of having inter-switch link, inter-switch link, inter-switch link. So if it's in a real environment, in a real scenario whereby you have your VMs, you have your data center switch, you have your firewall up and all that. Um, you also, so that interface where that server is coming into, on your distributed switch, the uplink is going to be the uplink interface is going to be a trunk. On your physical switch, that's on your physical interface that's connecting to your host server, the physical bare metal server that's running your VM environment or your vcenter and all that. mm, you configure that interface for inter-switch link. So you configure that as a trunk, you also configure inter-switch link under that interface. Also, if you're also connecting to another switch, configure inter-switch link on that switch so that this switch also understands the concept of what do you call it, of private VLAN. That, oh, I have some private VLAN, yes, so I can reach those private VLANs. Yeah. So in summary, I had let me give you some backstory. I was labbing, I was doing some lab, and then we have a VM where I had a server running vcenter and all that. I have a couple of VMs. However, if you don't configure inter-switch link on that interface, you find out that you won't even learn the MAC addresses of those VMs. However, when you configure inter-switch link on that interface, connecting to those VMs, you find out that you are learning the MAC addresses of those servers, and you can ping them. Yeah. Yeah, so this one is an SRX, just trying to represent a firewall. So in a typical environment deployment, if probably this VM virtual machine is trying to go to another virtual machine in another VLAN, the default is to throw it to this firewall to inspect and find out whether this guy actually has permission to go to another VLAN. Yeah. So the Promiscous, but there's actually an IRB here, so this guy can reach all these servers. That's that. Um, so yeah. So configuration. This is majorly Juniper set. So sample configuration PVLAN VLAN. So we said set VLAN. I'll paste this also in the part of the video. I'll paste this config there. Set VLAN 50. So VLAN 50 is our vlan-id VLAN 50 private VLAN isolated pv-com 501, that's our private VLAN community. Then you come here pv 500 vlan-id 500. This is our um that's our isolated VLAN. They also come here isolated, no, sorry, pv 500. Yeah, that's our private VLAN. So pv isolated VLAN 50 P500 community VLAN. So this is just the way you state it. Then again, like normal interface, this is how you configure them. Interface mode access, ethernet switching, VLAN members P500. So just like the same way you configure normal access interface. However, if you want to configure a trunk, interswitch trunk, so if you have a trunk interface, you state interface mode trunk, then you must configure this interswitch link. It's very important. If not, the other switch won't even understand, won't recognize those other secondary VLANs, which won't recognize them. Yeah, so that's very important. So a normal trunk interface doesn't have interswitch link, but you must configure interface. Also, when you are connecting to a server that is hosting, that has a distributed switch and all that, is a distributed switch, a virtual switch, distributed switch. So you must configure that interface on the physical switch with interswitch link. Yeah. So use cases. Private VLANs are useful in various scenarios. Network segregation. They allow for finer network segmentation without changing IP addresses. Secure hosting. They provide isolation between customers in a hosting environment. Backup network. They ensure that backup clients can only communicate with backup servers. I also gave you some scenarios. I mentioned PVLAN improve security by isolating devices within a VLAN. So if a server is compromised, let's say in isolated, the attacker can't just hop to another VM, even if he's using whatever tool. So that's the first line of protection. Reduce broadcast traffic and it's cost effective as they use existing VLAN infrastructure. So another thing you need to note is that you don't need to create a different set of IP addresses for the secondary VLANs. Whatever subnet you've created for the primary VLAN, that same subnet that the secondary and isolated VLAN are going to reference. The only comes to play in terms of the layer 2 side. That's where the isolated and isolated and community VLAN feature comes into play in terms of the layer at layer 2 level. I need to PVLAN, improve security by isolating devices in VLAN, reduce broadcast traffic, cost better they use existing VLAN infrastructure. Disadvantage: complex configuration and management. Yeah, limited functionality compared to other security solutions, potential performance fatality from fully configured. Complex configuration and management, well, I don't see that, but if, yeah, so you have to know what you are doing, yeah, when configuring that. So this is a lab. We'll look into this in a couple of next videos. So yeah, thank you guys, and please watch a couple of weeks. We'll be dropping the next video. We'll be labbing this and having a deeper view of what PVLAN entails. I also spin up, have my vcenter environment and servers here. So stay tuned. Yeah, thank you. If you have questions, please ensure you drop it in the comment section. I will ensure to make sure I respond to them. Thank you very much. Yeah.